Hey, good morning. Welcome to another episode of AI Buzz. My name is Nick, and I have some great stories for you today in the world of artificial intelligence and machine learning. I'll talk about how you can use AI, and researchers are using AI to stop elephant poachers, how Fujifilm is using AI for ultrasound applications. There's an awesome photo editing software called Mask AI that I'll talk about. And lastly, MIT is trying to study how objects move when they're pushed. Gets very interesting. Stay tuned for all of these stories and a bunch of side stories, I'm sure. Let's get started. So, researchers are using AI to stop elephant poachers. In 2007, the Microsoft founder Paul Allen released the Great Elephant Census. It was a survey of all the elephants in Africa. Over the next years that the study took place, it found that the population of elephants dropped by 30%. So researchers all over the world jumped on this and tried to develop ways to not lose any more elephants to poaching. It's become a devastating problem. One of the approaches that they began to rely on was artificial intelligence based, so that they could track the elephants as well as poachers. So this had been done before. Instead of trying to estimate properties of the elephants, such as population and movement patterns from aerial footage, so video footage of the elephants, this had issues with completely identifying all of the elephants, since some of them like to not hide, but they will go under heavily forested areas and thus cannot be found from aerial video. So in this article that I'm talking about, researchers from Cornell tried a much different approach. So the study was led by Peter Rage at Cornell. He's a Cornell researcher. Instead of looking at video footage, he instead planted audio recording devices in the forest. Reg placed 50 of these custom devices in the tops of different trees. He had a certain distance placing formula to figure out exactly where he should place these devices. And then he essentially would hit record and let it sit there for months and months and record everything that it heard, including elephants. And then after several months went by, the researchers returned to collect the devices and the data. And as this went on, the researchers were able to gather thousands of hours of recording from each of these 50 devices. So they solved the problem of they needed data. Now they have a new problem of how do they sort through all this data. The researchers quickly realized that this would not be possible or efficient. It may be possible with enough people, but it would certainly not be efficient, especially not when you have tools in artificial intelligence that can help you out greatly. So they turned to one of these approaches to sort through all of that data and try to find the most useful parts of it. Rage decided to use a neural network approach to solve this problem, and what he ended up doing, he and his team, they converted all of this collected audio into visual spectrogram images. So taking audio data and turning it into an image that represents all of the different sounds and pitches and frequencies that are going on in that recording. And then applying a neural network to that to analyze it and tease out the different things that it's hearing. So they called this the Elephant Listening Project. And they were able to do this very well. They were able to essentially hone in on different elephants and were able to develop some models to try to predict how many elephants there are in this kind of grid that they had set up with those recording devices. However, they heard something that was perhaps bone-chilling. They were hearing gunshots in these recordings. And so they developed another specialized tool to hone in on just those gunshots, so they could attempt to catch poachers in the act. So they developed these two models, one to actually predict how many elephants there are, and then another to actually try to, in real time, hear gunshots and recognize it's a gunshot, and then they're working towards a tool that could perhaps alert local authorities or something along those lines to say, we heard a gunshot in this area where there's elephants, it's likely a poacher. And there's other teams out there that are working on kind of these integrated analytics tools that'll be able to visualize things such as this, such as events that have happened that people should be alerted about, as well as snares and things that could indicate people are trying to poach animals in Africa. So I think this suite of tools and all these researchers that are working on this, it's a great cause, and it's a very good application of artificial intelligence, machine learning, and can't wait to see how these tools will help preserve some of these populations in the future. Next up, Fujifilm. Fujifilm is a leader in optics, including cameras and medical imaging devices. They've been around for a while. The company has seen an evolution of technology over the last few decades. They've been right in the middle of it. They've been working on staying up to date with the latest and greatest, and they're one of the survivors of all these tech booms. This week, in one of the Washington Tech Summits, the company showed their first mobile ultrasound device that was debuted back in 1998. So it's pretty impressive. The speaker on stage is holding this, portable ultrasound, which is one of the first back in the late 90s, and even back then, that's pretty cool that was developed. So they're showing how medical imaging could be made portable. However, in order to really get useful information out of an ultrasound, a medical doctor is needed to actually interpret the scan and reliably translate this into what it means. So Fujifilm is now working on a new product called Sonosight that will be able to translate ultrasounds in real time without necessarily needing a doctor to make sense out of them. Sonosight is collaborating with the Allen Institute for Artificial Intelligence out in Seattle to help build a model that can translate ultrasound images into useful information for patients. Some of the clinical data that they're using is from a collaborator, a hospital, as well as a clinic in Boston. So ultrasound images have a huge advantage over other types of scans, perhaps not in how much information they can tell you, but in terms of actually doing the scan, they're a pretty good bang for your buck. They're much cheaper, obviously very portable. They were portable back in the late 90s, as Fujifilm showed, and they're also much faster and just easier for the patient and probably the doctor than MRIs, CT scans, X-rays. Speaking of X-rays, there's no extra exposure to that harmful radiation with an ultrasound. So there's a big push for being able to interpret ultrasound scans, and since you can already have this scanner be portable, what if you could have a portable scan that could tell you right on the spot what is going on? And that's really what Fujifilm is pushing towards. Researchers are continuing to work and build a training set of labeled veins as well as organs within ultrasound images so that their suite of machine learning tools becomes better. And one day they want to be able to portably take an ultrasound and describe what is happening inside your body. Cannot wait for that. That is just simply amazing. Combination of hardware and software will really lead us to some great medical advances. this technology is similar to a piece of software called CM Triage that I covered several episodes back. It's from the startup Cure Metrics, and they're doing something pretty similar. They're triaging mammograms, that look for breast cancer based on severity. And so this is the same principle. The real-time analysis is going to allow patients to know if something's wrong, like almost immediately after the scan. These things predict very, very quickly. So while the patient is still sitting there getting the scan, they can know if they have something seriously wrong, and then act fast. And that is crucial in the medical world. Instead of getting a scan and waiting a week for your doctor to not call you, and then you calling your doctor, and then another week passes, they get back to you, and then now you have your data point to go off of, and then you have to schedule all these other appointments with other specialists, wait for their scans. This process is not efficient when you have a highly aggressive tumor, for example. So Fujifilm doing some great work on their new software, Sonosite. Excited to see where that goes in the next years. Photographers will be happy to hear that there's a new tool on the block to help create masks in software such as Photoshop. So masks are concepts in photo editing software that allow creating and selecting a very tight outline around the object that you're interested in, and extracting it out so that it can be used as part of a multi-layered image. So for example, you'd use a mask to extract out an image of a bird from a wooded area. So you'd be left with just the bird, a tight outline around the shape of the bird. The company Topaz has released this product called Mask AI, which utilizes computer vision and is able to create masks from these objects in photographs. The underlying technology uses a 3-level approach to build these masks. So there's an automatic mask finder, which is just amazing. It can find the object that's in the best focus in your image, and it's going to say, that's what you meant to take a photo of. And hopefully the thing you're trying to take a photo of is not in worse focus than everything else in the image. So it's able to find that main focus of your image. And with this automatic mask feature, it can automatically identify the main object. And then what it can do is it gives you kind of a base for starting off. So it's able to trim it pretty well. And then the next step is to actually manually begin to help it out. So manually tune those regions. They have 2 brushes. So these are the second and third levels that they discuss. So they have a broad brush to kind of include larger extra areas that the auto mask did not detect. And then lastly, they have a fine brush this is for the real professionals who are going almost pixel by pixel of trying to get the best mask they can. So those 3 levels enable creating a really very professional mask. And then what you can do is, once you have this outline, there's a button in the software, Compute Mask, and you push that, and then boom, your object is extracted from that image. And there's a great YouTube video from the YouTuber Ryan Mentz that shows this program in action that I would suggest checking out. You could just search Mask AI, Ryan Mentz. It uses 3 different photos of birds with backgrounds of varying complexity, and Mask AI did a very, very comparable job to Photoshop in terms of creating the masks. The creators behind the software believe that it has the same capability as Photoshop, and they say it requires a lot less manual work required by the user because of that auto mask feature. Believe in Photoshop, it only has manual features, so you have to, kind of outline manually everything. And then after the mask is created in Mask AI, there are many additional tools that the software has that you can apply to these images. A lot of different filters, things such as softness, adjust, and this seems like a very complete software package that's relying on AI to assist photographers and photo editors, graphic designers. Very cool stuff. We're going to see AI permeating all these different applications, and it's awesome. We're going to get even better photographs, even better graphic designs now with the assistance of AI. Last up, creating datasets is perhaps one of the most difficult things in machine learning. The entire accuracy and reliability of a model that you build depends on the input. In cases where there are no datasets publicly available, the dataset needs to be compiled from scratch. So MIT researchers are doing just that to develop a dataset for how objects move when they're pushed. This new dataset is likely to be the largest and most diverse of its kind, according to MIT. And the end goal is for robots to learn how objects are moved when they are pushed. This is a dataset that we don't currently have. There are datasets, but they don't show enough diversity in terms of objects that they're pushing to really generalize well. So this is extremely useful for building robots that'll be able to help us in things like warehouses. As robots become a more integral part of our life and start replacing some of our more manual jobs, these data sets will be very, very important. So in order to collect this data, the research team uses 3D tracking cameras as well as a robotic arm that can record exactly where and how an object is pushed. And for each unique push from the robot, that monitoring system records exactly how it moves. The team is calling this dataset Omni Push. It's going to be 250 unique pushes of 250 objects. So that's something like 62,000 unique data points. So each row of this is going to be a new object and a new push, and then this is going to be a very rich and useful data set to create future robots that'll be really useful for us. Another thing they say it could be applied to is video prediction. So this is something that be used in some of the Hollywood studios. So entirely in software, say you have an object that you want to look like it's being pushed. The technology is pretty good right now, but oftentimes you'll need to actually record that movement and then use some sort of CGI to bring that into the scene. They say that their data set could be generalized so that an object being pushed can be very accurately put into video entirely from software. So you can tell how hard, and then it will be able to predict very accurately the final location and kind of the mechanics of where that pushed object will land. That's about it for this episode of AI Buzz. Thanks so much for tuning in. Just a quick recap of what I talked about today. Talked about how researchers from Cornell are using AI to stop elephant poachers. How Fujifilm is betting heavy on AI and ultrasound, trying to get real-time interpretation of ultrasound scans with their portable ultrasound equipment. Talked about a new product from Topaz called Mask AI that is able to automatically create pretty good masks, comparable to Photoshop at least, according to most. And lastly, MIT is compiling a one-of-a-kind dataset to learn how objects are moving when they're pushed. I'll be back very soon with another episode of AI Buzz. Always a lot to cover in the world of artificial intelligence and machine learning. Can't wait to come back with some new stories. Thanks so much for tuning in. I'm your host, Nick. Bye.